All right, kiddos, welcome back. It's good to see you guys all again. This is going to be lab station number 5, which means it is our second to last lab station. We'll only have one more after this. So today's lab station requires us to have a few materials. We're going to need a measuring tape, a beaker with some water, a paper towel, a non-permanent marker, and some scissors, and then of course a calculator and a timer for our lab. All right. So, before we start the lab, let's go over our 4 properties of water, just like we did last time. So, number 1, water sticks to itself. Number 2, water sticks to other substances. Number 3, it dissolves many things. And number 4, it absorbs large amounts of heat. So, hopefully those are becoming very familiar by now that we've done 5 of these labs and you're getting the hang of it. So, what we're going to do first in this lab is I'm going to cut a strip of paper towel just off the edge. Doesn't have to be very big. Just a strip like this. Next, I am going to take my marker, and I am going to draw a nice sized dot on my paper towel. Like so. All right, the next thing I am going to do is I am going to measure where the dot is on the paper towel so that at the end of the experiment, I can determine how much that water had traveled and the speed at which it traveled. So I'm going to go ahead and measure, and it is 18 centimeters long. So I'm going to keep that in mind. I'm going to write that down over here so I don't forget. 18 centimeters long. All right. Then I'm going to put my paper towel in the beaker with water. Now before I do that, I want to start my timer because we're going to want to calculate the speed at which the water travels up the paper towel. So I need to start my timer before I put it in. So I'm going to get my timer ready here. I got it zeroed out. And then I'm going to slip my paper towel in and hit start. And I will move this so you guys can watch it. Push my camera down here a little bit. All right, and now we just wait and see what happens. And I know it's kind of hard to see, but you can start to see that the water is slowly making its way up the paper towel. And we're at 26 seconds right now. We're getting closer. It's about an inch off from the dot. Getting closer. We're not quite at a minute yet. And if you turn it to the side, you can see that the water level is right about here on the paper towel. So we're not quite touching the dot yet, but it is working its way up. Now, while we're waiting, you can think about those properties of water and determine which one you think this is showing. Remember, property number 1 is it sticks to itself. Is water sticking to itself in this situation? No, it's not. Number 2 is that it sticks to other substances. Is water sticking to other substances in this lab? Yes, and the other substance would be the paper towel. So that the water is able to stick to the paper towel and work its way up, and it actually just hit the dot. And now we're going to get to see what happens once that water travels all the way up to our black dot. It does take some time. We're at 2 minutes. Ooh, and if you can see what I see, it's starting to bleed, getting a little bit of a purple color at the edge. Not a lot is happening, but you can start to see it's working its magic. That water sticks to that paper towel all the way up until it hits the dot. And because this marker is not a permanent marker, the marker will bleed when the water hits it. So that dot is going to start spreading out as that water goes up to it. And you can see the water is about halfway up on the dot right now. And I can start to see like a purple bleeding color in there. My dot's gotten a little bit bigger, no longer perfectly round shaped. So you can see that water is making it all the way up. Turn it around here so you can see it. Starting to get a good bleed going. You can really start to see how it's changed. While we're waiting too, we can think about how we're going to calculate speed. Recall from other labs that we've done that you calculate speed by dividing distance divided by time. The distance it traveled, we know, is 18 centimeters. The time is still being recorded right now, but whatever we will get, we will divide that by 18 centimeters, and that will be our speed. I will get the board ready to help you guys calculate speed. I'm not sure where I put my marker. I'm gonna go grab the marker real quick so I can help you that. You keep watching. So I went ahead and wrote out the formula for you guys so that you can see how you calculate, oop, you can't see it, there you go, speed, distance divided by time. And as you can see from our dot, it's really starting to bleed. It kind of looks like a heart shape right now, and originally it was a circle shape. So I'm going to go ahead for distance, which is over here. I'm going to put 18 centimeters in because that's what we measured our paper towel at. And we don't know what the time is yet, so I'm just going to leave it like this so far. And my time right now is 5:25. And you're really seeing a good bleed. I'm starting to see a lot of different colors, not just the purple, some blue in there too. We're going to give it some more time to keep moving. And notice that the ink is moving up because the water is moving up the entire length of the paper towel. And we want to let the water get all the way to the tip of the paper towel. Otherwise, our speed divided by 18 is not accurate because we didn't let it go all the way up. So if you were only going to calculate how far it took to get to the dot, then you would have to measure from the edge to the dot. We measured the entire strip, so we need to allow our water to work its way up the entire strip to make sure that our data is accurate. And thinking too, what other ways in which do we make an experiment more accurate? How can we make this experiment more accurate? Definitely doing it more than once. Having multiple trials ensures that your accuracy is high. You want to get the same thing over and over. You want it to be repeatable. And that means that you're going to have a good and accurate experiment. Looking good. We're above the dot now. We've got about an inch to go. But the water has started to slow as it's moving up. I'll check our time here. We're looking at 7 minutes so far. As you can see, our dot has expanded a lot. Really starting to see the bleed of those colors too. Really purpley, some blue, and the dot is now over the edge of the beaker, which before it was not. It looks like our water has kind of started to slow and make its way to a stop. Now it's not quite at the edge of our paper towel yet. So what we're going to need to do is when we take this out very carefully, we're going to want to remeasure to where the water stopped at. And I also need to stop my timer here. And then we'll get out our measuring tape and we'll go ahead and remeasure so that we have accurate data, which from the point it stopped to the edge is actually 15 centimeters. So go ahead and change this to 15 centimeters because it kind of stopped before it could go up the entire paper towel. And our time is 8 minutes and 45 seconds. Now, we cannot divide it by 8.45 because that doesn't make any sense. You have to take the minutes and you have to convert them into seconds, which we all know 60 seconds are in 1 minute. So what you're doing essentially is you're taking 60 and you're multiplying it by 8, which gives me 480. And then I have to add the 45, so plus 45. And that will convert this into only seconds, which is 525 seconds. So let me explain that one more time. You can't use it in minutes and seconds because that's two different types of measurements. So you have to take the minutes and you have to convert those into seconds by taking 8 times 60 because 60 seconds are in 1 minute. And then you add the 45, which gives you 525 seconds. Now you take 15 and you divide it by 525 to get your speed. So 15 divided by 525 should get you 0.02857. So I'm going to erase here, make this a little clearer for you guys. We had 15 divided by 525, which got us 0.029. And this is centimeters per second. So your answer should be 0.029 centimeters per second. And one more time, I'll give you a good look at what happened to our paper towel. Look how much that dot changed, bled, and ran down our paper towel. Pretty cool, huh? All right, we'll see you guys next time for our very last water station lab. Bye, guys.